So welcome back, and today we're not going to be working in the workbook. We are going to just be trying to understand some of these things that happen to functions, okay? And we're going to dive right in, and we're going to look at, first up, all right, we're just going to put a point on the x-axis, right? And we're going to move that point around, and what we want you to observe is that no matter where that point goes, it always has a y value of 0. Okay? Points on the x-axis have a y value of 0. Does it make sense? It always makes sense. Here's a point on the y-axis. And we'll notice that no matter where we drag it, its x value is 0. Okay, right. So let's turn those points off. And now what we're going to do, we're going to look at a function. And the function that we've chosen to look at first up is x squared plus x minus 2. Right. What we're going to do now is we're going to look at some transformations of that function. The first thing we're going to do is we're going to look at that function shifted up or down. Okay? And the way we're going to shift it up or down, okay, is to actually add a number at the back. So now we've actually got two functions plotted on top of one another. Okay, but so the one is the red one and the one is the green one. At the moment, they're exactly the same. If I add a number to the green one, right? So I'm just going to add a bit, right? So what I've done, and I want you to look at where that plus 1 is. We've got the function, and then we've added 1 at the back. And what's happened is that the function has actually moved up by 1. Every point on the green function is 1 greater than it was before. If we were to subtract 1, the graph would move down by 1, right? So notice it's exactly the same function, and then we've subtracted 1 at the back. Right, we subtracted 1 after applying the function. If we were to subtract 2, it would go down 2, right? It would go down 2. Every point has dropped down by 2. Just remember how we would find the y-intercept of a graph. We would find the y-intercept of the red graph by letting x be 0 in this equation. If we let x be 0 in this equation, we get minus 2. But if we let x be 0 in this equation, we get minus 4. And we can see that's our y-intercept. The graph has dropped down by 2. When we add or subtract a number at the back, all right, then what happens is that the graph shifts up or down. So there it is on the screen, just below the picture of myself and above the picture of Simi, all right. If we've got a function and then we add q at the back after applying the function will shift up if q is positive, down if q is negative. Does it make sense? It always makes sense. Okay, so what we're going to do now, we're going to turn that function off. And what we're going to do next is we are going to actually add a value to x, to each x, all right, before we apply the function. Okay, so I'm going to draw another function now. At the moment, they're identical. But if we were to add, say, 1 to every x value, okay, now we're just going to look, I want you to look specifically at a point on the red graph. Okay, let's just turn the blue graph off for now. If we look at a point on the red graph, this point over here, it's 2, 4. All right, so when we put 2 into the function, we get 4 out. Okay, now what if we were to add 1 to our x value before we put it into the function? All right, so just listen to that carefully. What if we were to put x plus 1 into the function? Now, what value of x would then give us 4? Right? Now, because we're going to add 1 before we even start, when we put 1 in, we're going to get 1 plus 1, we're going to get 2, and that's what we're going to put into the function. This point is actually going to move 1 to the left. Let's just have a look at that. All right, so let's draw that graph, and let's add 1. Half 1. And notice that point, which was at 2, 4, is now at 1, 4. And the reason it's at 1, 4, it's exactly the same equation, but we've added 1 to every x before we apply the function. All right, to every x before we apply the function. So the point that used to be at 2, 4 now happens at 1, 4. Right, if we were to add 2, then that point would move one more across. Okay, there it is. Okay, and now that point is, the graph has moved 2 to the left. And we've added 2 to all the x's before applying the function. This one, a lot of people say, Paul, it's backwards. It doesn't work how we expect it to. And maybe you can remember it like that. But it actually does make sense if we stop and think about it. When we add, the graph moves left, right? And when we subtract, the graph moves, sorry, when we add, the graph moves left, and when we subtract, the graph moves right. Okay, all right. So there it is. Okay, and obviously we can if we subtract, you'll notice it's now moved 2 to the right. If we subtract 3 from every x, look at that. The original function was x squared plus x minus 2. Now we've got x minus 3 squared, x minus 3, and minus 2. And notice that the function has moved 3 to the right. Okay, the next one that we're going to do, right, I'm going to turn that one off. And the next one that we're going to do is we are going to put, let's just turn that off as well. We are going to now put a negative in front of every x. A negative in front of every x. Okay, so before we apply the function. Okay, so let's think about this point over here. 2, 4. We are now going to put a negative in front of the x before we apply the function. So when we put negative 2 into this function, negative 2, which is over here, all right, then it's going to become positive 2 and it's actually going to give us 4. That point's actually going to go across there. And what we will get, we will in fact get a reflection in the y-axis. When we put a negative in front of every x, our graph reflects in the y-axis. Okay? All right? The next one we're going to show you is that if we put a negative in front of the whole thing, in other words, a negative and open brackets, all of that stuff. Have a look at this function, the brown one. All right, I'm just going to ask the computer to show us the its name. All right, come up now. Just want to get its equation, sorry. Okay, we're not winning here. Let's just try here. Sorry, I don't know why it's not showing the equation, which is very frustrating. I'm going to show you what it looks like on the side over here. That's what the equation looks like. All right, so there's the equation. It's the negative of the whole thing. Okay, and when it's the negative of the whole thing, it reflects in the x-axis, and that's reasonably easy to understand. Let's just think about this point over here. This point was 2, 4. So when you put 2 into the red function, you get 4. But now we're going to find the negative of all of that. So 2 actually goes down to -4. Okay, it makes sense. It always makes sense. Right, we're going to do another graph, and we're going to go through all of that again. We're going to use a different function this time. Okay, so I'm going to turn that one off. I'm also going to delete that and delete that. All right, and we are going to turn that off. All right, and we're going to change this function. And I'm going to change this function to 2 to the x, 2 to the power of x. Okay, anybody before, I haven't changed it yet. What does it look like? What does 2 to the x look like? It's an exponential graph that goes uphill from left to right. How do we know it goes uphill? Because the base is bigger than 1. There it is. That's our function. Now we're going to do all those transformations again, right, with this function. Okay, so the first one we're going to look at is the vertical shift. How do we move a graph vertically? Well, what we're going to do is we're going to add a number at the back. All right, let's add, so here's the graph. Let's add, this is the green graph, let's add at the back, say, +1. And what you'll notice is that the green graph is going up, okay? It's shifting up. What's happening, if we subtract, it goes down. The asymptote is being affected, right? Remember the asymptote's a horizontal line there. And the range is also being affected. The range of y values that's possible is also being affected. Okay, right. So now let's look at the next move, which is not that's a vertical shift. Let's turn that one off. Let's turn that graph off. Okay, and let's now look at the horizontal shift, which is going to move the graph left and right. Okay, let's look at how that looks. Okay, so now we're going to look at the horizontal shift. And remember, the horizontal shift is we're going to add to the x value before we apply the function, right? So let's just look at a point here. Here's the point 1, 2. Now, if instead of drawing this function, we drew the function f of, say, x plus 1. Now, remember, when we put 1 into this red graph, we get 2 out. What must we put into this function to get 2 out? Well, in fact, we must put 0 in here, because that will then put 1 in. So in other words, this point, instead of being there, will be there. All right, let's have a look at it. So there's our graph, okay? Let's just see. Yeah. There's our graph, it's the blue one. And if I add 1 before I apply the function, okay, so notice the 1 is being added to each x, all right? Notice what actually happens here. The 1 is being added to each x. And the graph has moved 1 to the left. Okay, let's look now at that same point. We know that when we put 1 into the red function, we get 2 out. But what if this function was not there, but what if we drew the function, what if we drew the function f of x minus 3? Right. Now, in order to get 2 out, okay, remember, when we put 1 into the function, we get 2 out. So the x value that will give us 2 out is actually 4. So if we plot f of x minus 3, that point will actually happen over here. And let's do that. Let's plot let's subtract 3. Okay, that's subtracting 1. Look at the equation, look at the blue equation. It's 2 to the x minus 1. We're subtracting 1 and then raising to the power 2. That's subtracting 2, that's subtracting 2.5, and that's subtracting 3. When we subtract from an x value, before we apply the function, the graph moves to the right. When we add, it moves to the left. All right, so that's all summarized in your workbooks, okay? But now let's look at the last one that we're going to look at, and we did look at it before on the parabola. We're going to look at it on the exponential as well now. Let's put that back. Let's turn that graph off. Right. Now let's just think about our reflections. Okay. At the moment, and we keep talking about this point, at the moment, this point is there. Right. Now, if this is the graph 2 to the x, if instead of drawing 2 to the x, I drew f of x is 2 to the negative x. Okay, so I'm going to put a negative in front of my input before I raise to the power 2. Okay, we know that when we raise 1 to the power of 2, we get 2. All right, there's that point. But now, if we're going to put a negative here, then that point will actually go here. Because negative, so in other words, if I put negative 1 in here, I'm going to get 2 out. Because the negative is actually going to make it into a positive 1. So in other words, it's going to behave on this side like it used to behave on that side. And we're going to get a reflection in the y-axis. Okay, I'm just going to turn that off, and I'm going to show you what we're dealing with here. Reflection in the y-axis. We put a negative in front of every x. Okay, I'm going to just try and delete this stuff, and I'm not sure that I'm going to be able to, but I will try. Okay, yeah, I'm struggling. Okay, but what I'll do is I'll draw the function anyway. That's actually what it looks like. 2 to the negative x, the purple one. Okay, and then lastly, we're going to look at the last one, and I'm afraid I'm struggling to clean my screen here. Let's just see if I can do it. Refresh the views. No, okay, that's not working. And okay, the last one we're going to look at is the reflection in the x-axis, and that involves putting a negative in front of the whole function. So now the negative is not going to be there, it's not going to be 2 to the minus x. The one we're going to draw now is going to be 2 to the, sorry, it's going to be the negative of 2 to the x. Okay, it's going to be the negative of 2 to the x. It's going to be a brownie color. F of x is going to be the negative of 2 to the x. In other words, we're going to work out 2 to the x, and then we're going to change the sign. So in other words, this 0.12 will actually drop down to there. Let's put that function in. Okay, and it goes there. Right, I hope that helped. I'm sorry the technology was a little bit glitchy, but hopefully it helped our understanding of this stuff. Understanding is all important. In the next lesson, we're going to take you through each of the functions that we've studied and just remind you how they all work. Okay, right, we look forward to seeing you then.